So in these more or less 40 minutes, we'll take a quick look at what uberAgent is. First, I'll start by explaining the architecture, explaining the product very briefly with the help of a few quick slides. And then the majority of the session will be a demo. You'll see the actual dashboards, actual data collected by uberAgent. And yeah, hopefully this will be, well, ideally this would be interactive. I realize this is a little bit difficult given the remote connection, but if there are some questions, Alex, maybe if Alex could collect them and ask them via the chat, and I'll try to answer them. I'll keep an eye on the chat window. Okay, so let's dive in. Now, what is the coolest thing about uberAgent? Well, from our point of view, that's two different things. For one, it provides really great and rich data, visibility into your end-user computing environment that is otherwise very hard to get. So we provide very high-quality metrics, and at the same time, the product is extremely easy and intuitive to use. So it can be set up in minutes instead of hours or days. And once it's set up, you'll figure out right away what is what and how to navigate the product. So people seem to like that quite a bit, and we're improving on our user experience with every single release. So things should become even easier over time. Now, let's take a look at what the product actually consists of. So we have a data collection agent, obviously, that needs to run on those endpoints that you're interested in, that you want to monitor. This agent, it runs as a Windows service. It has an extremely small footprint, so you'll see some numbers on the slide in front of you. So approximately 15 megabytes of RAM, a little bit less than 0.5% CPU, and no disk I/O at all. The latter is especially important in a virtualized environment. And this works because the agent, it collects all the data which you're interested in, and it just buffers it in RAM until it can send it off over the network. And no worries, in case the network connection is not available for a certain time, a minute, half an hour, whatever, the data is not lost. It will be buffered in memory and sent off the next time the backend can be contacted. Now, as you may have known or may have seen on this dashboard, the backend used by uberAgent is Splunk. Now, those of you that already know Splunk, they will know that Splunk is an extremely versatile platform that can be used for all kinds of different use cases. Splunk is very, very popular in the security space, but not only there are lots of different use cases, and Splunk is basically a product that can ingest vast amounts of data from many, many different sources. And then it makes that data searchable, and it is possible to provide a very nice, easy, and intuitive UI user interface to navigate that data. And no worries, you don't have to do that yourself. As you can see on the slide, we ship a Splunk dashboard app, a pre-made user interface which you just install with 2 or 3 clicks on your Splunk server, and then you have all the user interface or the dashboards, around about 45 different dashboards that come with uberAgent. And one of the great things about using Splunk as a dashboard is that, as I mentioned, Splunk can do many, many different things, and you're not limited to looking at data from one source at a time. It's very easy to create custom dashboards that combine that data from different sources, for example, from uberAgent and from some kind of file server, NetApp, for example, that you might have, and a few other sources, and combine just the metrics that are extremely relevant to your organization on one page, and see if that would make it easy to see how one component influences the other. So if a database or backend server is not available, it's quite logical that the front end is not available too, and that kind of dependency would be perfect to highlight with a custom Splunk dashboard. Now, looking at the architecture, it is extremely simple. That is part of the reason why it's easy to set up and easy to maintain. You install the agent on any end user computing machine that you're interested in monitoring. So it starts with Windows 7 and of course it goes up to Windows 10, the list of supported platforms, and we support all relevant or major virtualization or remoting architectures like Citrix XenApp and XenDesktop, VMware Horizon View, Microsoft RDS, and a few others too. So you configure that agent with the address or with the name of one Splunk server or with a list of multiple Splunk servers if you have a larger environment. And that's it. Those Splunk servers will take care of distributing the load in collaboration with the agent. And then you put the dashboard app on those Splunk servers and you're done. So if you're doing it for the first time, installation might take half an hour. If you're doing it a second, third time, you'll probably be ready in less than 10 minutes. Another cool thing about Splunk is that it scales extremely well. So it basically automatically distributes load across machines. So if one machine is not enough for the data, for the load, you just install a second one and basically that's it. Okay, that was a very brief introduction. With that, I'll switch to the actual dashboards and show you a few of the capabilities and a little bit of the data that uberAgent collects. Now, let's start with one thing here, user sessions. In a virtualized environment, especially in XenApp, in a multi-user environment, of course, you have many different sessions per user, and whenever you're you need to do some sizing calculations. You need numbers like these, those that you see in this section, averages for all sessions. So the obvious question is, well, our average user session, how much RAM does it need? How much CPU cycles does it consume? How much disk utilization is there? How many IOPS? And so on. And without a tool like uberAgent, those numbers are pretty hard to come by. So I did a sizing project a while ago before we had uberAgent, and it took me a week to come up with these and a few other numbers that uberAgent just gives you like this. And if you're interested in trying out uberAgent or using it in a consultancy project, we're always happy to send out eval and also consultant licenses, which for free, which you can use in your real projects to figure out what's going on at the customer side and help you with your sizing calculations, for example. Now, below these average numbers, which are already very valuable, you see different metrics per session. So you can see immediately this session of this guy here consumes, generates way too many IOs, and it consumes way too much CPU time. So that guy is me. So apparently I'm kind of a power user, and those other sessions seem to be a little bit, have a little bit smaller footprint. Good for us. Now, below those charts, you typically have a data table with most of our dashboards, and that table in this case shows you most of the information that we collect for every single session. You can see that see when the user logged on, when they were last seen. In case the user already logged off, you would see in this column here the end of the session. You see the remoting protocol like ICA, so we're kind of old school, we're still calling it ICA, not HDX, and a lot of performance-related information. Especially quite a few different latency numbers. So latency is extremely important. You don't want it, but you always have a little bit of it. And if you're unlucky, well, if you have a problem, then you might have a lot of it. And latency is the time to take. It takes some operation to complete. In this case, a request to a disk to be completed, either to store some data or to read some data. And the longer that is, the longer applications take to basically to do the user's bidding. And if latency is high, even for a short period of time, users will notice the applications are becoming sluggish and reacting not snappish and not well enough. Another interesting latency metric with any Citrix system, of course, is the average ICA latency. So what is the response time from the user's device, potentially a thin client, to the XenApp or XenDesktop server in the data center? Okay, so moving on. Well, when you think about a session, the session obviously starts with the logon of the user, and logons in XenApp, of course, are a very, very big topic for obvious reasons. And the problem with logons is that they always take too long, and that the operating system does not have any useful tools for diagnosing what is happening during that time. Now, uberAgent does. It fills that gap pretty effectively, I would dare say. So again, here you have an average section which gives you an indication of what the logon duration is in this environment. As with all of these dashboards, you can always select the time range. You can see we a little bit above. We've pre-selected the past hour for you, but you can switch that to any time, any point in time or any time range in the past you're interested in. So you could switch that to the last week, last month, or a specific week, a few weeks ago, a specific day, 3 days ago. Any point in time that you're interested in, that you'd like to analyze. Okay, so you know what the average total duration is in this environment, and of course the next few numbers, they give you the average duration of the major phases, like how long does it take on average in this environment to load the user profile. And well, 5.7 seconds is not too bad, I would say. Well, potentially average. How long does it take to process group policy? How long does it take to run a Logon script configured by the Active Directory user account? The next one is how long does it take to run a Logon script configured via group policy? And then finally, if you're publishing full desktops instead of published applications, of course, the shell starts typically explorer.exe, and that takes a little bit of time too, sometimes a lot. And that last column here gives you the average duration of the start of the shell. Now, those numbers in that first row, they are just averages of all the logons in this time range of the past hour, which we selected here. In that this colorful chart below that, it shows you the duration of all these phases over time. So each of the phases gets a different color, and we can see by looking at the height of the various colors how long each phase took at each specific point in time. So for example, let's say we're interested in a user profile, how long that takes to load. I can just hover the mouse over this legend here, and then the others will be darkened, so I can see very easily what the user profile duration is. Or let's say I'm interested in group policy, same here. So you get the picture. Now below that, below we have two charts that show you kind of the worst users and the worst hosts. There might be a specific host where logons take longer than others. For example, you'd immediately see that here, for example. And again, below that, we have a data table that shows you quite a bit of data about each individual logon. So for example, let's look at this first column here, first row here. You see that a user with a complicated name ending in 39 logged on to a host called RDS3. You can see at which time the logon started. You can see for this specific logon how long that took, the total duration of this specific logon, and the duration of the various phases for this one individual logon. Now, that's very nice to have and very nice to see, but what about troubleshooting logons? If you wanted to know what is going on during this logon, well, the information you see in this dashboard might not be enough. So just by clicking on one of these rows here, you'll get a very detailed you drill down to a very detailed dashboard we call single logon that shows you all the information uberAgent collects about each specific logon. So you get this out of the box for every single user logging on any of the monitored machines. And the data presented here is quite extensive. So in addition to what you've seen on the previous kind of overview screen, well, for this logon, you see something like what we call pre-logon init, which is interesting in a XenApp use case. So that's more or less the time it takes for the user to click a link in Storefront until the user is actually logged on to the session on the XenApp host. So that's more or less the time it takes the broker to set up prepare everything that's necessary to actually log the user on. Now, you also see quite a bit of information about the Active Directory infrastructure that was involved in this logon. So you can see the AD site, you can see the domain controller authenticating this user. Something that can be extremely relevant is the duration of this phase we call DC discovery, so domain controller discovery. This basically tells you how long it took for the machine logging on the user to talk to Active Directory. And if that duration is long, if that time is high, you might have an AD problem or potentially a DNS problem. Now, scrolling down just a little bit, looking at this section, group policy CSEs and GPOs. If you have a high group policy processing time, or if you just want to figure out what's happening during that group policy processing time, well, uberAgent shows you group policy is modular, and Microsoft called a module client-side extension with the acronym CSE. And uberAgent automatically detects which of the more than 40 or 50 client-side extensions that ship with Windows are being used for every individual logon. And uberAgent also detects if third-party vendor like Citrix in this case, if they add a module of their own. So as you can see, there's a module for Citrix profile management and a few others. And uberAgent detects those and measures the processing duration of this one module for this one logon, and it shows you that in that second column. It also shows you the group policy object where that setting was configured. And since I'm highlighting this one, this Citrix profile management, you see, well, apparently it was involved in the logon, but it is not configured in any GPO. So how can that be? Is that the bug in the product? No, well, not in our product. It's probably not a bug in the Citrix profile management product either. This is kind of a specialty. It actually is involved as part of the logon, although it is not officially configured. That's yeah, you'll see that with every logon to a XenApp box with a Citrix profile management installed. But typically, for example, when you're mapping a few drives via group policy preferences, you're going to see something like this. Client-side extension named group policy drive maps. Its processing time was pretty short, 0.2 seconds. That is pretty good. And you can see next to that the name of the group policy object where that was configured. And in the rightmost column, you'll see the return code of that CSE, of that group policy module. 0 is developer lingo for success. Everything else is developer lingo for bad things happening. So in case you get a return code, you might want to Google that and figure out what it means. Now, below that, we have the coolest thing regarding logons that uberAgent provides. Now, we collect information on every single process that is part of this specific user logon, and we show you in the leftmost column the lifetime of that process. We detect when it's being started relative to the logon start. We measure its lifetime, and we show that graphically using these colored bars, so you can see immediately which process started when. Okay, I'm now seeing your camera, thank you. And seeing your, yeah, hi everybody, yeah, see you waving, thanks. Okay, so using these colored bars, you can immediately figure out when a certain process during the logon started, when it ended. You can see the parent process of that specific process. You can see for each process the full command line if you hover over this, this column here, for example. uberAgent tries to auto-detect the type of process, and in a few cases that is extremely relevant. For example, if you try to figure out what's happening during a logon script. Logon scripts are very opaque, well, intransparent. You get potentially dozens of processes, entire process structure where one process calls another one. In this case, the process that was actually started as part of the logon script was this batch file here, cmd.exe, executing the batch file gplogon.cmd. You'll see the full path to where it resides. You see what other processes this command line executable calls. On the right-hand side, you see the CPU and memory utilization of this specific process. So that's great stuff to troubleshoot individual logons and figure out what takes how long. And one thing I should have mentioned earlier is in those first two columns here, you can see the how long it took the user profile to load and group policy to process, and at which specific time that happened during the logon. So you can see the group user profile was loaded pretty quickly after the logon started. Then when the user profile had been fully loaded, group policy processing started, which is the same for every single logon. And then all the other things happen that are required to set up this session. Now, one thing that is, so in other words, let me start differently. This has been part of the product a little bit now. One thing that is very new that we are adding and releasing in just a couple of weeks is the same information for user logoffs. So it may not be as, user logoff problems may not be as common as user logon problems, but if you have logons that take a long time, you have the same problem as with the logons. There's basically no tool available to analyze what's going on during the logoff in this case. And starting with uberAgent 4.0, as I mentioned, it's probably, it should be available in a couple of weeks. We'll show you the same kind of information that we do show for the logon, also for the logoff. Okay, now on to something different. With the current version, uberAgent 3.7, we added a feature that is quite can be quite interesting. Think of folder redirection. Please raise your hands if you love folder redirection. Okay, no raised hands. But who uses folder redirection? I would guess quite a few of you, it is a popular technology because there are not many alternatives. And well, with folder redirection, I did quite a few sessions on that with Aaron Parker, who might be even in the room or not. I saw he was attending yesterday, and Sean Bass on folder redirection. And the problem is that you're trading high I/O during logon for a constant I/O during a session. So you have a dependency on good file server performance all the time. If the file server has some kind of a hiccup or experiences just, let's say, 10 minutes of slowness anytime during the workday, users will notice immediately, especially if you're redirecting app data. And for figuring out the performance of your SMB connection, because I'm not saying CIFS here, maybe Aaron is here and listening, he would have a little fit now, I guess. Anyway, to figure out the performance and the latency of your SMB connection, we added this functionality you're seeing right now. So we do measure the average latency of your SMB connections, in other words, the connections to your file servers. We measure that for reads, for writes, we measure the IOs, and quite a few other things. In that colorful chart, you can see the latency over time. Sorry. Okay, so you can see not the latency, the IOPS over time per network share. So you can immediately see that, for example, here we had a connection to one server, to one backend machine with quite a bit of disk I/O or SMB I/O was going on. Then the charts below that, they show you how much data has been transferred to each share individually, and we show that for reads and writes. So in this case, blue is read data volume and green is writes. We show you the data volume over time below that. So there has been a peak here, and we show you the latency over time. Below that, you have a data table for listing all the different SMB connections with very detailed information. So if you want to troubleshoot a specific connection, that is extremely helpful. And this also enables you to figure out if there has been a peak in latency, in other words, slowness of the file server for a specific duration. Today, yesterday, a week ago, you are absolutely capable of analyzing it with uberAgent, even in retrospect. So that's no problem at all. Okay, now, so we started talking about network connections, which SMB connections are a certain specific type of. uberAgent records not only information about net SMB connections in particular, but also about all kinds of network connections in general. So we do show you the data volume and the latency grouped by, you can group that by many different things. You can, in this case, you see it grouped by applications. So here, for example, you can see Google Chrome, how much data it's sent and received in the selected time range, by default again 1 hour. You can see for all of these selected applications the data volume and the latency over time. Below that, there's again a detailed statistics table. And let's take a look. For example, we have, of course, GoToMeeting here, which I'm using right now. Let's see what GoToMeeting was doing. So by clicking, or is doing actually right now in this, has been doing in this past hour. So by clicking on this GoToMeeting row, you get a drill down view. And for now, I'm seeing all the hosts GoToMeeting has been communicating with on the internet. Well, basically anywhere. I'm assuming it's not on my network. In some cases where GoToMeeting uses IP addresses and reverse DNS lookup is not possible, we will show you the IP address. In all other cases, we'll show you the DNS name. And it is quite interesting to see expertcity.com. I don't know, is that a provider in Australia, or I'm interested. It's funny that GoToMeeting is using those URLs, or that is.
I believe it's.
Okay, sound is not perfect. So, well, it might be one of the providers or one of the backend services used by GoToMeeting, probably in the States. It makes more sense, I guess. Okay, and then extremely interesting or relevant is the latency of the connection here. Let's say, well, I don't have to, well, this is a live session, and if latency is bad and is spiking, the session might have a problem. So this graph in red here, it shows me when that might have been. Okay. Now we have, if I'm not mistaken, more or less 10 minutes left. I have 2 or 3 additional features I'd like to quickly show you. And again, if there are any questions, I'm happy to answer. Just Alex, just please collect them and ask them via the chat. That would be easiest. Okay, so talking about network performance and latency and so on, there is, of course, with every network, there are things that are going wrong from time to time. Please, of course, don't ask the network guy. He's always going to say, well, my network doesn't have problems. Maybe other guys' networks, but still, if you do suspect there might be a problem, we have a new dashboard that is going to be released with version 2.0 in a couple of weeks, as I said. And it shows you gives you quite a great overview of what might have gone wrong. The first indicator is network availability. This calculates how many of the attempted connections actually succeed. So we have about 99.25% here, so that's probably not too bad, although in a really good environment you would see 100%. Next to that, we see the failed connections and so on and so on. But looking at these charts here, you can see exactly which applications had connection failures and at which point in time. So for example, I'm hovering over Firefox right now, or I could also use take a look at GoToMeeting, and we see we had in one connection failure where GoToMeeting wanted to talk to a different host, and that was not possible. If those spikes are getting higher for a certain point of time or a certain application or a certain backend, as you can see, you can switch to target host, for example, and you'd see let's see, let's see what we get, if that is any useful. So we have, okay, 2 hosts on the internet that have experienced connection failures, and also quite a few reconnects and retransmits. So what is this? Trying to put the mouse on it. So, okay, there's one of my machines. Okay, of course I don't have any network problems. It must be something else. So I guess you heard that before. Let's switch back to the application view, and that could be more interesting. So let's see if GoToMeeting had reconnects. Not really, so that should be pretty good. And retransmits, quite a few retransmits, not really many, but a retransmit is of course a sign that the connection was not extremely stable. And below that, again, there is a data table that shows you the number of problems in various categories like failed connects, reconnects, and retransmits per application, and you can switch that to various views or sort by a specific port, a specific host, and a few other things. Okay, now all these things, they already affect user experience quite a bit. Let's take a look at something else that affects user experience a lot, and that is when the UI of an application simply doesn't respond in a timely manner. Now, uberAgent detects that whenever there's well something not reacting to text input, to mouse clicks, or whatever the user is trying to do with the application, and whenever such an unresponsiveness or a delay is longer than 200 milliseconds, it is picked up by uberAgent and analyzed. So this dashboard shows you the total wait time for all the applications in the selected time range, the average wait time whenever something went wrong and the user had to wait on an application. On average, that took 3.1 seconds with this data in this environment, and how many times users had to wait overall. These numbers, they enable you to, well, that's great for managers if you want to, a manager is typically not interested in things like IOPS and stuff, but if you tell them, well, our users had to wait for, let's say, on average 10 minutes per day or 20 minutes per day, that might be a good point in getting them to invest in better storage, better CPUs, whatever you need, wherever there's shortage in your environment might be. We show you, of course, the which hosts are most affected by unresponsiveness, which users, and quite a few other things, and of course which application, how many instances of unresponding user interfaces, and so on and so on. So there's lots of data available to figure out exactly which application is behaving, is snappier than others. Okay, and the last dashboard I wanted to talk about is something a little bit different. A topic that is becoming more and more important, that is GPU usage. Usage of GPUs even in virtualized environments is becoming more frequent, more common. And one thing that is becoming relevant when you're using GPUs is, well, which application makes use of the GPU how much? And there are not many tools that can answer that question. uberAgent is one of them. It shows you the percent of compute usage that any specific process uses. So how much basically CPU, how much of the silicon on the GPU is used. In this case, when you're playing back video, for example, the Windows Media Player, that's something that's very typically handled by the GPU, but quite a few other applications, like even the Microsoft Office applications and, for example, Adobe Photoshop, they make use of certain calculations on the GPU. And this shows you that it is happening, to what extent, and what the overall, on a different dashboard we show you also what the overall load on the GPU would be. Okay, so this basically concludes my presentation for today. Well, if you're interested in trying out uberAgent, I mentioned it's extremely easy to install. We're always happy to send out eval licenses, and just take a look at uberagent.com. Thank you very much.